Hi, Dave.
Hi, Kevin. How are you?
Good, thanks.
Hello, David.
Yeah, Joel,
Hi, Dave.
we'll give everyone a couple of minutes to join. I'll get some water in the meantime. I sent a couple of notes. I'm not sure what happened, right? My intent was um, that all people will come in and participate, and we'll have a discussion. What do we do at CDX given how fast AI is moving?
Yeah, I saw that. That's why I joined.
Right? Yeah, but I think it had the opposite effect because
Okay.
nobody nobody's joining, and it's just three of us. Um,
We'll get more done.
Yeah,
yeah, yeah, yeah,
so three of us can talk.
yeah, yeah, yeah,
Yeah.
yeah. I was hoping we were gonna have wider participation, is what I'm trying to say. I didn't mean to scare off anybody. Yeah, so right here's what prompted my thinking is when I look at what AI can do today. Um, we've been working on workflows, right? We've been working on file formats. And I think that's done deal. AI can do most of that. It can understand all of the data. It can collect it together. It can figure out the workflow, right? Um, in terms of where do we, right, what do we focus on at CDX, right? Do we still try to focus on these implementation details that AI can do? Or do we move one step up and look at the integration of chiplets, right? What is needed there from us to accommodate that,
I'm
right?
just trying to build the tools. So,
Yeah. So I can tell you a couple of things from OCP's point of view. So OCP, as an organization, wants to bring in AI to help with all these activities, which is notes taking and then going through the documentation and archival, the manual stuff needs to be fixed. So they are looking into some of those operational use cases of AI. Okay, that is going to be available to pretty much all the work stream across OCP. Now, the bigger question that you are asking, in particular, what will happen to specifications and interfaces? So everybody's jittery and just don't know how it will evolve. But one of the principles of OCP is we provide a forum for the industry to talk about collaborating with each other. So the key is, if right now the demand from the participants is that we work on a problem statement that they still need a solution, that we should kind of follow that. Uh, but the way we see all of this will change as opposed to just writing file format standards. There will be more like intentions, system level targets, system level specifications, and how all of that comes together. And, basically a method to inter to have various AI things interact with each other. So there will be a change, and I think we have started hearing from CEOs of Cadence and Synopsys that they will do a massive change in their tools and policies and licenses. So, but at the same time, they all are working with, at the moment, just one foundry, and that foundry just has 3D blocks as one solution that they think for foreseeable future will solve all the file format issues. In my mind, it's like, 3D blocks is kind of like not needed anymore either. AI can take care of it, right?
Yep.
So, but that is the solution. So I like your idea of asking folks what they think are the problems going forward that need solutions, because I can tell you there will be a lot of problems. I don't think our jobs are going away anytime soon, unlike what people think.
Yeah.
Somebody sent me a link yesterday for grants for a bunch of science-related things from the government. One of them is recentering chip manufacturing stuff and design stuff in the US. $5 to 5 million grants.
Okay.
Um, I'll put the link in the chat for you if I can find it. Let's see, around here somewhere.
You're sending that. I see a couple of people have joined us. We have Rob and Rudolf. How are you guys doing?
Doing okay. Hello.
Hi, Rudolf. Have you joined CDX before? Have we met?
No, this is my first time. I
Oh,
just
great.
wanted to check it out.
Okay. With can you do a quick intro for everyone, and we'll do the same.
Sure. I'm Rudolf Hoffmeister, and I'm a technical director at Max Linear, where I work on 400 gig per lane next generation product definition.
Okay. Awesome. Welcome to CDX then. Rob, have we met before? I apologize. Really
Yeah,
bad
I
with
don't know.
names.
I'm having some audio problems. Can you guys hear me okay? I don't know why it's
Y-
not using my headset. It's just using my regular PC mic. Can you guys hear me okay?
Yes, we can.
Okay, so I'm Rob Munoz. I'm a architect in Austin, Texas. I work on like government project type stuff, and I have led for the last several years an internal Intel work group, cross Intel work group on chiplets. And I think Satish used to attend this thing. I don't know if he still is, though. I
Yes.
haven't checked with him recently.
We haven't seen from him recently, but yes, he did attend some time back. And he definitely contributed and helped us push forward some of the CDXML and JEP30 work.
Yep.
Well,
Okay. Makes sense. Thanks. So I'm just trying to, get back in sync as far as what's happening in the rest of industry. So that's why I'm joining
yeah.
this. Though I notice that it seems like the announcements for this thing go out like right when the meeting starts, which is a little weird. But maybe everyone just expects it on their
Oh,
calendar at this time and knows to sign in right away or something.
I'll check with OCP how they set it up. We have a group CEO group that is dedicated to CDX specifically, that has all the calendar entries, and that one I know sends meeting notifications and invites a little bit earlier. Let me post that in the chat, and then you can subscribe to this group
Yeah,
and
I think
follow
I
them.
already subscribed, so I see a notice, but the notice for the meeting only happens like right when the meeting starts, as opposed to like
Oh,
a day or two before or something.
okay. Yeah, let me check on that. Okay, quick intro from me. I'm David Raskov. I lead the CDX. I've been doing it for a little bit. And CDX focuses on two pillars, data exchange, file formats, things like that, which are needed to describe chiplets. And on the other side, workflows that basically take that data and move it around to the different steps and produce systems made of chiplets.
Incidentally, so this is recorded. How do I look at the archive of recordings?
I think I have to update the wiki page for CDX. I have not done so. So I'll take an action item for that.
Okay, makes sense. Thanks.
The last couple of things we have been working on is test design kit, basically describing things that are necessary for test, for integration of tests. We are staying away from test standards, right? That's handled by IEEE. But then the question is, what kind of data do we need to exchange through the different steps of the test integration workflows to integrate chiplets? So that's one part. We've been separately looking at SI and PI design kits, see what data we need to carry for chiplets to allow easier integration at the next level. Those are the two things we have been working on recently.
Yeah, makes sense. I'll, once I get the link to the recordings, I'll try and go back and catch up on, some of the stuff that's happened since, and I'll check with my colleague Satish as to, why he's not able to participate anymore or whatever. And because I would hoped he was covering it, but I guess not. So,
So Rob,
Okay.
I have a question. Are you still with Intel?
yeah, I'm with Intel. Exactly.
Okay.
Intel Government Technologies now, though.
Okay. So because one of the big vectors that we were pushing in CDX some time ago was upon behest of Intel to continue with file formats to cover the design kits that Intel Foundry was developing, and then suddenly Intel vanished. So we put two and two together. We read the news and then kind of figured out that Intel doesn't need this anymore. So if there is any repeated interest from Intel, we'd love to know about it because we had done quite a bit of work with Satish and Lalita previously.
Yeah, I'll check with my colleagues and see. I'm on the government side, so I'm not with Foundry, but I'm not completely with products anymore. So, but I'll check and see what what their thinking is, and share what I can. Sometimes it's there's a firewall of sorts between Foundry and the rest of the company. So I don't necessarily always get the full story. So, but I'll ask.
Thank you. Yeah, so maybe I can introduce myself. My name is Jawad Nasrullah. I am one of the co-leads of Open Chiplet Economy project, which this particular work stream is a sub work stream of. So um, overall, in the Open Chiplet Economy, we cover the whole gamut of chiplet related issues, all the way from business down to nitty gritty technical details of design and architecture and implementation. So I was originally a few years ago very deeply involved in CDX, this particular work stream of design exchange. And at that time, obviously, we hadn't heard of AI in terms of its agentic capabilities. And all of us are now baffled by what we are experiencing and trying to think deeply, what might be the next set of problems that we would need to solve.
Yeah, it makes sense to your point, Jawad. I would think we collectively should figure out how, we can make things such that AI assistants can consume them and, automate almost all of the stuff required to, build the packages and systems, and, make all the, I mean, you're already working on the tool interoperability stuff, but the AI aspect means that machine readability and those kind of factors should also be factored into what we produce, I would think.
Absolutely.
Yeah.
I'll do a quick intro. Kevin Cameron. I work in EDA, semiconductors. Mostly I work on chip design methodology, more in the mixed signal space. So I'm trying to work on helping enable the chiplet system design stuff.
Yeah, I think the reason, Jawad mentioned, we have been kind of focusing on, especially last year, a lot of focus went on to a lot of work went into defining file formats. And with AI these days, I don't think the file format is the right data carrier, right? It's just, it can understand all of it anyway.
Yeah, I was in one of the other groups and they were like doing file formatty type stuff, and I said this seems a bit redundant at this point. It's like the machines can work this one out for you.
Yeah, exactly. I recently had experience. I needed to debug some simulations.
Mm-hmm.
So I gave the AI two VCD files and I asked it, hey, compare these two VCD files and tell me at which point they diverge. And it was able to figure out all the objects in the VCD file, its IDs, go and look at the waveforms, go and look at even what those objects were and tell me, hey, here this flops gets reset, but the output doesn't change, right? So that seems wrong. So it knew all of that. I didn't have to tell it anything.
Yeah, I spent the last 6 days or so doing the ISQED challenge, DV challenge. You had to do sort of coverage and other things and simulation and other tools. And at one point the coverage was like bad, and I said, well, can you fix the design so we get 100% coverage? Then can you do a SAT solver match to see if the original design and the one we have, which is 100% coverage, actually do the same thing, and see how that goes. And half an hour later, it's done. Essentially have 100% coverage.
Right?
I can tell you how to do that if you want. It's like So
Yeah,
I didn't check it all in, but it's somewhere in the ISQD
yeah,
competition files.
yeah.
Um, Z3 is the SAT solver, if you want.
Okay. Yeah,
Yeah.
right. And things like that, right? So uh, I guess the fundamental question is, what does chip design and chiplet design look like when the
Uh,
AI can do all of this
Yeah,
stuff,
in the
right?
AI era, what does it
Uh,
look like exactly? And what does that mean for, because it might be that it's no longer technical challenges, but maybe more commercial ones as far as how to make everything work together and interoperable tools, all that kind of stuff.
well,
Because
that's
I
why
was,
I'm pushing the open source stuff. I mean, if
yeah,
I've got a working open source simulator that's commercial grade that does everything. So it's like I'm looking for people that want to make that work for their chiplet system design.
yeah. And especially, yeah, even for tools, given as you mentioned, um, in many cases, I think right now it's possible. Just tell it, hey, I want you, as you mentioned, right? I want this tool to do this, right? I want to solve this problem.
Mhm.
Go and do it, and it will write you the code.
Yeah, I mean, I've got a thing called LTZ, which is supposed to kill off LT spice, where it's like um, fixed my environment so that it'll run Zeiss instead of LT spice, and it's Verilog A based, and you can do optimizations in the source code in Verilog A, which are not available in LT spice, and then so it ends up about the same level of performance. I didn't
Yeah.
write any of the code. You know,
Right?
I've
Yeah,
written no code since like
yeah,
Christmas. You know, I would say this is the
yeah,
most productive I've been in years. It's like
right?
nobody's getting in the way, which is the usual
Yeah,
problem at standards
yeah.
committees.
And even I had, I was trying to, we were doing experiments for the eight modularity group, and we were doing it with ASAP 7 libraries and those are CMC models. And then, right, the question is, how do you uh, plug in CMC models into ngSpice?
Mhm.
And I just asked Codex, right, go and figure it out. It worked a couple of hours,
Mhm.
ended up with final updated models.
Yeah.
It can simulate all the
Well,
standard cells in the ASAP7
yeah.
with
There's
ngSpice.
there's a thing I did with Zeiss, which so they use ADMS for the Verilog A
Yeah,
models, which sucks. So I said, okay, there's a package in C++ called GenAC, which does analytical stuff. So it'll give you differential equations out of like doing a bit of math for you with special C++ classes. So I said, write me something that translates the Verilog A into C++ that GenAC can understand, so I can then work out the partials and generate the C++ code using the partials, and then do something where you create regimes that match all the states for the conditions in that code and like make that work in Zeiss. So we got there, sort of worked. It's a bit unstable. I said, well, he said the IV curves work, but some of the stuff doesn't converge. And I said, okay, if you've got the IV curves, do table models for the stuff when it's not converging. So it did that. Then it worked fine.
yeah, yeah.
Like,
So, right,
and
so the
that's a PyMS, and you can probably include that in ngSpice if you want. I think they've got their own Verilog A at the moment.
right, so I guess right, I guess we're in agreement. Um, I don't know what to do about workflows and file formats, right? It, it just doesn't make sense that the
Yeah.
AI can write all of that data intake and exchange and conversion, right? We don't need to worry about
Yeah,
that.
so one of my things I'm looking at is like I've worked in the Cadence environment a few times, and you have to net list out to the simulators. And I was thinking it'd be much easier if the simulator just connected to open access. You tell it what you want to simulate, and it pulls all the models it needs. And then
Yeah.
you say, okay, I'd like you to go faster. So it uses the fast models. Or you say, I'd like to go slow on this piece. And then it uses the slow models. And if somebody changes the design, it tells the simulator and the simulator swaps it. It's like, it would just go so much faster than using Spectre with net listing. You know, trying to find a
Right.
customer who wants that's difficult.
What do you folks think is next? How would that whole design and workflow look like? What would that look like?
Well, I've done papers for the Chiplet Summit the last 3 years. And the original one was just federated simulation for chiplets. So basically, every chip has its own simulator, and then you stitch all the simulations together in the cloud and server farm to do verification work. And then like Rev 2 of that was where you're actually doing digital twinning from the sort of spice level into behavior or digital into behavioral models to make it go faster. And then level 3 is you switch that around and say, okay, just give me the code and I'll treat that as a spec for what you want. And I'm going to migrate that code and make it parallel, then put it on accelerators, and first level accelerators are FPGAs. And I'm halfway through the FPGA piece now with Claude. If anybody's got FPGAs and want to try stuff on, let me know.
Yeah.
I think Intel dumped Altera. That was probably not a good idea.
Yeah,
What did you say about Altera?
yeah. My former colleague Aurelian is on, who's on the Altera side now. So
Yeah, I
Yes.
worked at Altera like 20 years ago or something on a Verilog simulator project. There was a skunk project that dumped, but if you want a better simulator that does Verilog and VHDL and it costs you nothing versus paying Siemens, yeah, let me know.
Okay.
And there's an automatic will accelerate your code for tool flow that goes with it.
Yeah, well, I mean, Intel dumped Altera for obvious reason, right? That synergy servers and FPGAs didn't work for them, and so they just got it. They decided that the marriage should end, and they separated. So I think everybody's happy with the separation, both Altera and Intel, so far at least.
Well, it was a strategic mistake for Intel. Might be good for Altera.
Yeah, I think on both again, it was on both sides. Like I said, there was a bad apple on both sides. Everybody thinks that it was a mistake on both sides, and everybody's happy that they
Well,
separated.
I'll give you a number. I'll give you a number. So
Mhm.
so I said to Claude, okay, let's do a profile on code and see which routines would be good to accelerate. And I picked Verilator because Verilator does a lot of logical operations that are hard on a RISC processor. And we worked out what would go in the FPGA as an accelerator, which is single cycle over 30 cycles of code. It's like, and I said, okay, build me a soft core that has that accelerator. And it's done that. It's just, I'm at the point of trying to benchmark it at the moment of like, I can take a random piece of code, see what's slowing it down, synthesize the code into FPGA and load it up on a soft core and see what it does. And that's a prototype for an ASIC.
Okay.
And Claude's written all the code for me. I haven't touched anything. Yeah, I mean, I've got an FPGA board, an Altera one actually, Intel Altera, which I've never touched myself as far as programming, and I just plugged it into a laptop, loaded Claude, and said, "Hey, program that thing for me," and it worked it out. And it drives Quartus. You can put Quartus inside XPRA, and it can drive it for you, so you don't even have to learn Quartus.
Oh, okay, that's great. Even myself, I need to learn that because I'm still old
Yeah,
school where I have to open Quartos to do everything.
Yeah, XPRA is the tool you want to look at. So what it does is it lets you run an X application isolated so that Claude doesn't get confused about what it's trying to drive.
Okay. All right, I'm
And
gonna check that out.
if you want to drive a browser-based thing, you use Firefox Marionette. So I couldn't understand what they're asking for at the ISQED challenge. I said like, okay, how do we drive the browser? And Claude was a bit unsure, and I said, can you use Firefox Marionette? And he said, yeah, I can do that. So it was happily sort of submitting things away through this browser, gateway. I have no
Okay.
idea what he actually submitted.
All right.
Still trying to work out where I ranked in that one. I didn't get back to him. Next, I'm looking at the 20 grand for a placement project competition thing. See if I can
Oh,
make some money.
the practical.
It's an open road thing.
Is it open road or a practical?
The
I'm not sure if
Macro Place Challenge 2026. It's up on GitHub. 20 grand for beating replays, I think it is.
okay. Yeah, there's this company practical that's running placement challenge too.
Mhm. How much money are they offering?
I don't know. I lost it. Let's see. Yeah, practical 20. Yeah, it's the same one. The 20K grand prize.
Yeah.
Yep.
Put it in the chat.
Yeah, it's on GitHub. Yeah.
Mhm. Anyway, so the question is, what's the thing that's slowing you down at the moment, and how do we speed it up?
Yeah. What do you guys think about custom accelerators?
That's
Right.
what I'm working on. Yeah.
Because right now everybody's right. It's all OpenAI and Anthropic and these guys
Mhm.
and Google, right? And it's all TPUs or GPUs or in the case of
Yeah.
XAI, it's probably their own chip or
Yeah.
inference. Do you
Yeah.
think custom accelerators would make sense at some point for I don't know, custom models, or it's all going to be
Well,
one size
and
fits all?
that's why I did the last paper at Chiplet Summit on, like, how do you take code and turn it into hardware? Basically, you got a workload at OCP, and you say, I've got this big workload. Might be AI, might be something else. It could be like computational fluid dynamics. You don't really care. You say, okay, here's the code, make it go faster. Is the job, or make it use less power. You know?
Yeah. But I guess my question is, right, not only from the design side, yeah, we can do that. The question is, would actual hardware be built that is custom and purpose built?
Well, that's why I'm looking at the FPGA piece. It's the halfway house. So basically, if you can get everything onto FPGA, then that's a prototype for your ASICs. Which Altera should have done years ago, but never listened to me.
What about others? What do you guys think?
Missed that.
I mean, everybody else. What do you guys think about custom accelerators being built, actually built to accelerate specific workloads? Any thoughts?
I think I mean, again, at the end of the day, you have to be able to beat what the NVIDIA and other startups are doing today, right? And you have to integrate that very closely with the XPU, or at least with the CPU to do the acceleration. So I think it's a novel idea, but it's just that the market becomes a little bit saturated for that, and the performance will have to justify the investment. But
Mm.
I think it's a novel idea. It's just that it's something that need to mature. You need to mature really fast.
Mm.
With the speed of AI these days, not something that you can afford developing in more than 2 years, more than 18 months, actually.
Well,
Yeah.
I'm looking at getting things done in a few weeks at the moment with AI. You know, if you know what you want, it's not hard to get it done.
Yeah, AI plus FPGAs, right?
That's it exactly right. So yes, I mean,
Mm.
you want to say 18 months, I mean you have to from start to having the hardware in hands, it has to be less than 18 months, right? So
Yeah. But if somebody gives me the FPGA gear, I'll get my simulator running on it. And the idea for me is that I'm doing a software simulator where it'll have a go faster button. And if there's an FPGA there, I'll just use the FPGA.
Yeah.
No emulators, but nearly as fast.
Yeah. So the again the original question is, how does CDX help to to all of this process, right? To all right. Where do you think we can add
Well,
value?
the methodology I was proposing a while back was that, if you can run your stuff as software, and we can like decompose it into things that work in chiplet models and FPGAs, then we can go rebuild the rack for you with dedicated hardware. So it's not ASICs, it's just that the FPGAs, the accelerator processors, all those things. We can build you a specialized rack in a matter of days to weeks. If you want ASICs, it's going to take a lot longer. I mean, there's also the hard copy approach of like doing gate arrays still, which like has languished for years.
yeah, I think you say if you say if you want to implement those custom accelerator in the FPGA, that's what you mean?
I want to design an FPGA, and then I want to go to. I mean, I can go to gate array in a matter of weeks, probably. I can go to
Hmm.
full ASIC in months.
Okay. Yeah, I mean that's definitely doable. You have to just to remove all the crap around the FPGAs that makes it
Yeah,
typically the FPGA vendor they make it like
yeah.
general purpose, so they put a lot of crap around it.
That was a thing called hard copy when I was at Altera like 20 years ago.
Hmm.
But the flow wasn't there. It should have been fairly automatic, and I think like, for some reason they didn't really want to do it, or just couldn't write tools. One of the two.
Yeah, yeah. I mean, I think that is something that is definitely doable in the matter of again short period of time. You just focus on the fabric itself, nothing else. So, I mean, you still have to bring the data in and out of the fabric, right? But if you take
Mhm.
like very light interface, right, nothing that is very hard in terms of implementation, protocol, Ethernet, PCIe, and all those stuff. Just maybe a hard UCIe or a hard FileLight and
Mhm.
something like that
Yeah.
and focus on just the fabric. Yes, you can do that in a matter of time because it's going to be a lot of copy and paste in terms of the structure.
Mhm.
Yeah, so to respond to the question as far as what should CDX do, I would think we'd want to make it easy for someone to uh, build and integrate chiplets to stuff, whether those things like, hopefully we'll get FPGA chiplets or whatever, but uh, just make it easy to automate the whole construction integration process for this stuff to make these things really easy to use. You guys
Would that,
agree or see it differently?
That sounded good
yeah,
to me.
yeah, yeah,
Ease of
yeah.
use.
Yeah. I guess the question is, do we just here's a thought, right? Do we end up just with instructions for the AI? Hey, write in text form. Hey, here's the data sheet for this chip, or here's an algorithm for this tool. Go and do it, right? So basically, when I'm stitching something together, I'm more like working with agents that do different
Mhm.
pieces, and the overall agent just fixes it all, right? When I import a chiplet, do I just get its text description and what technology it's built on and what limitations it has and what features it
Yeah,
has, and let the AI
fast
figure it out?
behavioral models. If you got fast behavioral models for the digital stuff, I mean that's good enough
Yeah,
for
I
a
mean,
lot of things.
you need that. You need the hardware level, mechanical, electrical, all those type of of things to make it easy
Yeah.
to have
Yeah.
specs for these. And so I would hope we would have something that says, we don't necessarily have to be as picky about file formats, but we need to have stuff that makes it have this is the minimum level of information needed so that the tool can go
Mhm.
extract it and then use it to automate all the construction and integration type
Yeah.
aspects of things.
Yeah. I think that's stuff we've been doing here with like the ECXML, is it, and other stuff.
Yeah.
We need to know the mechanical outlines, and then like you want a behavioral model that tells you what the power envelope stuff is like, and then you want to run it and see if you can pack it with everything else in a box.
Yeah, but that would be, and I don't know, Kevin, to what extent you're willing to contribute some of the stuff you're doing or others, but it would be interesting, I think, to have like contributors, OCP, open source stuff. Here's some flows. Here's the tools they work with.
Hmm.
Here's some examples, and wow, I push a button and I'm able to, have everything work together. Right? Maybe do an example of here's, simple thing maybe would be simple-ish thing would be you have because the only thing now where I can buy third-party chiplets currently is HBM, right?
Hmm.
So maybe have something that says, oh, if I have an HBM chiplet, uh, here's what I need to do to go, and I have some other, my own SoC design or whatever. Here's what I need to do to go, put it together, so to speak,
Hmm.
and use that as an example of, hey, this demonstrates, multi-vendor tooling for I have uh, a well-defined chiplet spec with a few vendor options, and I push a button with these tools and flows, and voila, it figures out how do I get my package done, my whatever my SoC interface is. If though I'd probably have licensed IP for that part, but whatever parts we think make sense to try and automate, just to make it easy to use.
Sounds good. Who wants to start?
Well,
I
Kevin,
say
seems like you're.
the stuff I'm working on is all up on GitHub if anybody wants it.
Yeah,
So work in
yeah,
progress.
sure, but yeah, you may. Um, Again, I mean, contribute everything you're doing, and maybe have some suggestions as far as these are all the things that because to actually build, working system in package, you need to get the stuff, all the design files, and then there's all the EDA tool like checks that you do to make sure everything works before you actually push the button to manufacture it, or write the check, or whatever
Yeah.
euphemism you want to say to actually
Mhm.
manufacture the stuff. And so maybe flows and tools, maybe some of those can be open source. It seems like, Kevin, you're really uh, very conversant with all kinds of open source alternatives to some of these commercial things. But uh, either way, I mean, it seems like we would want to show examples of this is how you use it. Here are some published flows to go do it with some kind of white paper that describes, here you take this off of GitHub, uh, you put it all together, you push the button, and then your collection of agents goes to work, and then here's what it produces, and any other input as far as uh, if there's
Mhm.
any user interaction along the way. These are the types of things that typically need human guidance during the process, or whatever. But it seems like get all that stuff
Yeah. I'm
uploaded and
mostly coming
documented.
at it from we need to do the verification stuff. So can we build a verification environment for the chiplets?
Yeah,
And
which
then having built that, can we spin it around and make it a design environment?
yeah, it makes sense because to your point, I mean, memory is probably easiest thing because it's
Hmm.
passive, right? So I mean, but that's why I was
Yeah.
suggesting it as a simple example. But to your point, on a more involved thing where you have some kind of active accelerator or something, then the um, multi-chiplet verification validation type stuff becomes a lot more important.
Hmm.
Right. I mean, I'm not saying it's not important for memory, but I'm just saying it can get more complex when you have these interacting entities, especially if they were produced by, completely third-party folks that did not collaborate before trying to put them together.
Yeah.
So
I
Rob,
mean,
I
sorry.
have one question. Since you are working on some government stuff, and we are under the impression that U.S. government is not interested in CHIPS Act anymore, is there some revived interest in chiplets and AI, some of the problems they want solved?
Yeah, I mean, I think there is definite interest in general in the government space. They tend to be low volume consumers of technology, and so they're really interested in stuff like, it actually would align with what I said too, as far as if there is technology that greatly shrinks the upfront R&D costs, like to produce the first unit of something,
Yeah,
then
I
that
mean
is
that's
super
the
interesting.
FPGA, that's the FPGA and
Well,
gate
yeah,
array
not just
space.
FPGA stuff too, because sometimes you can't use FPGAs for everything. But I mean, even when you can't, to the points made earlier, FPGAs are awesome vehicles for, prototyping. So before you spend the, millions to produce hardened silicon, you better make sure everything works really well in an FPGA environment, or, whatever other environment you have to really vet what you're doing.
But
But I'm just
the gate array environment is something where you can make gate arrays by the million, and you just like do the mask layers to get them to do what you want.
Sure. So
Yeah.
to your point, it'd be great to have flows that say, I have something I want to be able to quickly integrate it, maybe even something to, if I have some special sauce thing I want to do for acceleration, make it really easy just to take that thing, plug it into some infrastructure and go off to the races, right? As far as the, super low cost, low schedule way to do some kind of focused acceleration, low NRE, all that kind of stuff. I mean, that would be interesting. And I think if that were done, that would excite a lot of folks, not just on the government side, but, there's all kinds of things where if you could do this inexpensively, then that would open up a lot of opportunities.
Well, I think the turnaround on doing the gate array stuff is a matter of days, or less, once you've got all the flow in place.
Yeah, that makes sense. And it's
I mean, you can get
unfortunate.
3D printers that work at the level of nanoscale these days. So you just print the wiring you want for, it's the EUV layer that's costing you in time. But the top level wiring for something like a gate array is not super expensive.
Yeah, and I'm to your point, Kevin, I'm surprised,
Mhm.
on when Intel was together with Altera, we had a gate array thing that, we discontinued. It seems like, seems like we didn't invest properly in that. My personal opinion, not the official opinion.
Well, the problem with some of this stuff is that some people's stuff runs too hot. Intel and NVIDIA both like to make things that run very hot, and then you can't die stack them. And that causes problems. So I'm looking at the die. What's die stackable? What can you do as 3D monolithic? And how do we get there? So it's reimagining some of these tool flows to get rid of the power hungry things. I mean, I worked with somebody before Christmas who was trying to do analog compute. And the problem with trying to do analog compute is there aren't verification tools for that. So I'm looking at like, okay, let's go build the verification tools, because just stitching stuff that's already done together. And
yeah, I mean, it seems like that's not the only analog compute thing, right? I mean, if you got to make sure it works across all your process voltage, temperature spectrum that you need to operate
But that
within.
again is something that the AI can help you with. You say, okay, because I've got stuff where I can model things, where I pull in that PVT stuff and say, okay, here's a model that understands what the range of operation is. So you can get the effect of Monte Carlo, but in one go. So it's just different modeling techniques for a lot of these things to work, but you can't get it out of synopsis and cadence.
Yeah, it seems challenging, right? I mean, there's
There's
Yeah,
a
and
lot of
once you
solved problems that just haven't made their way to the customers because
yeah,
the EDA companies, the way they work is they buy startups and they make them business units and then they sell stuff by the license hour.
yes, I mean,
Nobody's selling on results.
yeah, I mean but still that it seems like whenever you stray from mainstream synchronous digital logic, you're in a no man's land where you don't necessarily have great tooling to go,
Well, you don't.
you know.
That's why I'm building the tooling. Yeah, it's like it's like if I mean I've spent years at IEEE trying to get people to fix tools and standards and things, and like suddenly it's like okay, I don't have to wait for those guys anymore. I can just do this stuff in open source without having to consult a bunch of people at IEEE. You know,
Sure. So anyway, general guidance or my input, you know, for me being the first time at this meeting, so take it with a grain of salt, is make the stuff easy to use as far as development integration of chiplet things. And Kevin and team, if if you want to contribute your stuff to do any of these interesting analog things or whatever, that's great. I mean, I'd say the more the merrier, as long as it ends up being wrapped up in some kind of easy to use framework, so folks can take what they want that is important for their application needs and put it all together very easily and quickly.
Yeah, that's very interesting feedback, Rob. Thank you for that. So what I gather is what you're thinking is even before we get to FPGAs and designing Verilog, is there any way to look at how do we integrate this stuff and what does the architecture should look like, right?
Well, there's the whole spectrum of things, right? Because I would see it as like a continuum of, I have something I want to go do better or something, and maybe some of the stuff that Kevin talked about might help me figure out, is this, I have a section of things that I want to accelerate. How can I do that? And then if I don't have an existing implementation of it, maybe there's tooling or whatever to put it in an FPGA or some other thing, maybe. And that would be a continuum of initially FPGA, then maybe gate array, or maybe hardened ASIC or whatever. And then let's assume that somebody, maybe it's me, has produced this thing in some kind of chiplet form. Maybe it's something that already exists from a third-party ecosystem like HBM memory. Then how do I take that thing that has been produced, maybe semi-separately, and integrate it in with the rest of my SoC and a system in package type thing? And that would be the vision, where it's a whole continuum of development, as far as you initially maybe do stuff just with software things, then FPGA, then you harden it to, if the economics suggest that that's the right thing to do, to gate arrays, or hardened leading edge silicon, or maybe trailing edge silicon, depending on what all you're doing, and put it all together. And the flow, tooling, flows, interop to make all that easy to do. That seems like would be a good grand vision to have here for eventually what we want to achieve. And then
yeah.
I would suggest we focus on what's we think is most important but not yet good enough there, and try and knock out those things.
Good plan.
Yeah. No, I think that's awesome. Yeah.
We've done a bit of this stuff in the AI hardware software co-design group. If you dropped in on that one at all.
Yeah, and we don't want to replicate what someone else is doing. I'm just saying, it seems like the charter of this team is to make sure like tools, flows, and methods all are interoperable, easy to use, that kind of thing. So that should be our primary focus. And if someone else is, doing some other aspects that we could, link to or reference, great. And, we shouldn't
Yeah.
be picky about, like, it doesn't have to be other stuff in OCP or anything like that. It can be other efforts, whatever, as long as it's
There's
practical and it works.
Yeah, there's a bit of an overlap in some of the other groups. Like last year, we were doing a lot of stuff in the Open Atomic Ethernet space. On like, okay, if you have an accelerator for something, how can I tell it's there, and how do I know what it does? So
Yeah, so there'd be a
yeah,
whole bunch of like discovery type stuff, some of which can be,
yeah,
pre-integration, most of which hopefully is pre-integration, some of which maybe needs to be done dynamically or something.
yeah. So
So
so there's things like, okay, you things pop up on the network, and you can ask them what they are, and it says, I'm an XPU, I can do PyTorch well, and you say, okay, if somebody's asking for PyTorch, I'll use you to accelerate their PyTorch library. So there's a bunch of orchestration stuff like that to do, which like some of which I've got half done already. But
sure.
it's
Yeah,
like
so
it's a question of I've only got so much bandwidth. If I can find people to work with, we can get through this stuff very quickly.
yeah, I mean, I would think for this work group, we'd want to focus on something easy-ish but has commercial relevance so that
Hmm.
we're not just
Yeah.
producing,
Well,
science project type things.
so the chiplets are just chips. So basically, at some point you're going to say, okay, I'll put my chiplet on a board and let people try it out, which is sort of hardware in the loop. So you can have a rack full of weird chiplets on boards and say, okay, how do I orchestrate these weird chiplets on boards to do my particular thing? And then having worked that out, then how do I make the stuff on an interposer that does it in a fraction of the space and power?
Folks, I'm really liking this discussion. Let's continue next week. We're at the top of the hour. I unfortunately need to drop off for my next
Okay,
meeting.
look
I
forward to it.
think this is great. Let's continue talking next week then.
That's fair.
Yep, sounds good. Thanks, folks. Hopefully I didn't upset the
Not,
apple cart here in this thing.
not. This is great. I really appreciate your view, Rob. And I hope you can join us more often, and we can have these
Yes,
great,
so I'm going to try
great
and put
discussions.
this. Yeah, I'm going to put this on my calendar and try and join. But I'll be on sabbatical starting like third week of April to third week of May. But I'll join for the next few weeks here.
Okay, awesome. All right, folks. I'll see you next week then.
Thank you.
Thanks.
Yeah, bye.
Bye.